Hi there, and welcome to the polynomials and quadratics exam questions. I'm just going to go through 9 questions here, trying to take a good spread from polynomials and quadratics and just show you how these are marked. Okay, so for this one here, we've got given that x plus 2 is a factor of that polynomial, find the value of k. Okay, so for part A here, x plus 2 being a factor means that we know when we synthetically divide using our nested form, that if it's a factor, the remainder at the end of that should be 0 because it goes in exactly. So when we run through with minus 2, because x plus 2 bracket gives us a root of minus 2, when we run through that, adding down and timesing up, we know that the answer we get at the end should be 0. Okay, so that's minus 2k minus 12 there, which makes minus 2k minus 10 here. And that has to equal 0 since x plus 2 is a factor. Okay, now minus 2k minus 10 is equal to 0, then we know 2k has to be equal to negative 10, which means k is negative 5. Okay, and in part B, hence solve the equation when k takes this value. So firstly, our equation is turned into 2x cubed plus x squared minus 5k now, because this k is turned into a minus 5, plus 2 is equal to 0. Now that's a polynomial equation, we do need to factorise it, but actually we have already factorised it up here. We know that x plus 2 is a factor, so the divisor x plus 2 could be our first bracket, and the quotient is going to come from under here. Okay, so that quotient is 2, started off as x cubed, so this is now x squared, so 2x squared minus 3x. I know that here k is now negative 5, so negative 5 add 6 is just a positive 1. And then I'm just going to factorise that to solve. So x plus 2, this one's going to be a trinomial. It's going to be 2x and x. 1 and 1, both negative because I've got a positive and another negative in the middle. So there is my factorisation, which means that the solutions are x minus 2, x is equal to a half, and x is equal to 1. Okay, so marking. Okay, firstly, for setting up your synthetic division, just that top line gets you your first mark. For running it through to 2k minus 10 gets you your second. And the third mark is for both setting it equal to 0 and then solving for k is equal to negative 5. In part B, the first mark is for setting up this divisor times quotient, and the second mark is going to solve that equation. Okay, question 2, expressing this in its fully factorised form. Okay, now we've got no clues here for what those factors are going to be, because it's not telling us anything that is a factor. So the numbers we're going to choose are going to be factors of 10. That is the one clue we've got. So running through my synthetic division again, I'm going 1 minus 4 minus 7, 10. I'm going to try 1 minus 1, 2 minus 2, 5 minus 5, 10 minus 10 until I get 1. Okay, so let's go through with 1. 1 comes down, times it by 1 is 1, add down minus 3, minus 3, minus 10, minus 10, and add down 0. Perfect. So f of 1 is equal to 0, therefore x minus 1 is a factor. Now if you didn't get 0, you know it's not a factor and you'd have to go back to the drawing board and try again. Okay, now this can become, well, x minus 1 from the factor, and then from my quotient under here, I'm going to get x squared minus 3x minus 10, and then just finish off that factorisation. This is going to become a trinomial x minus 5x plus 2. Okay, marks here. First mark for setting up your synthetic division, second one for running through, third one for divisor times quotient, and fourth one for completing your factorisation there. Okay, question 3, you've got 2 bits of information about f of x here. One, when it's divided by x minus 2, it gives you the remainder of 114. And secondly, one factor of f of x is x plus 1. Okay, so firstly, we know when we divide it by x minus 2, so that is setting up a synthetic division with 2 as your divisor. and 2 minus 1 p q 12. And give yourself more space here because you know it can get quite messy. The remainder is 114. So that means this box at the end, because that is the remainder, should be equal to 114. So we'll run it through to, that's 4 now, that's 3, 6, that's p plus 6, which becomes 2p plus 12, which becomes 2p plus q plus 12, which becomes 4p plus 2q plus 24. And when we add down there, that's 4p plus 2q plus 36. And we know that has to equal 114, since remainder is equal to 114. Okay, so just that's there. And then the second one, factor, is x plus 1. So that becomes x, x equals -1 on the side. So 2 minus 1 p q 12. We know because it's a factor, there's no remainder. So whatever comes here should equal 0. Okay, so that's 2 minus 2 minus 3, 3, p add 3, minus p minus 3, q minus p minus 3, which becomes p minus q plus 3, which becomes p minus q plus 15, equals 0, since x plus 1 is a factor. Okay, now what we have here is we have two equations that we're going to solve simultaneously. So firstly, just getting all the numbers together here, that's going to be 4p plus 2q is equal to 78. And then this one here just rearranged so it matches up with this. Other equation is p minus q is equal to -15. Okay, now I'm going to solve it just a good old National 5 way. Oops, apologies. So 4p plus 2q is equal to 78. And when I multiply the bottom one by 2 to match up the p's, it's 2p minus 2q is equal to -30. Because the signs are different in the middle, I'm going to add them together. So 6p is equal to 48, which means p is equal to 8. And then lastly, I'm just going to substitute back in. So p is equal to 8 means that that's 32 plus 2q is equal to 78. 2q is equal to 46, which means q is equal to 23. Okay, I'm marking now. Okay, so working our way back from the top here. The first one for setting up the equation, okay. The second one for running through and setting it equal to 114. The third one for setting this p minus q plus 15 to 0. The fourth one for starting to solve your simultaneous equations, and your fifth one for p and q. Okay, question 4. We're looking at the roots of the equation are equal, find the values of k. Okay, as soon as we start talking about equal roots, we know that's the discriminant. Okay, more specifically, the discriminant being equal to 0, because the discriminant equals 0 for real and equal roots. The problem here is that this is not set up to use the discriminant because it's got brackets and it's not equal to 0. So the first thing I'm going to do is break out those brackets, which will give me x squared plus kx minus x minus k is equal to -4. And then add 4 to both sides, just so I've got it equal to 0. Okay, so minus k plus 4 is equal to 0. Now that means the a term for my discriminant is going to be 1, because in front of the x squared I've got 1. In front of my x's, well, there's an x there that's got a k, and there's an x there that's got a -1, so b is k minus 1, and c is 4 minus k. Now I've just swapped them round to keep the negative second rather than first. And we know b squared minus 4ac has to equal 0, and that's since the roots are real. So because we know the roots are definitely real, we can make the statement at the start, the discriminant is equal to 0. So this is k minus 1 squared minus 4 times 1 times 4 minus k is equal to 0. k minus 1 just becomes k squared minus 2k plus 1. And then minus 4 times 1 is just minus 4. Minus 4 times the 4 is minus 16. And minus 4 times minus k is plus 4k. Tidy that up, k squared plus 2k minus 15 is equal to 0, which is a trinomial that factorizes. Plus 5 minus 3. So k is equal to negative 5 and k is equal to 3. Now again for our marking, okay, your first mark is for multiplying out brackets and setting it to 0. Your second mark is your statement about your discriminant having it equal to 0. And your third mark is for substituting in correctly. Your fourth mark is for simplifying to your k squared plus 2k minus 15. And then your fifth mark is for solving correctly at the end. Okay, number 5, again we're talking about real roots. Find the values of k for which the equation has real roots. Now, there's two situations where you can have real roots, where it is real and distinct, so greater than 0, and when it's real and equal, so equal to 0. So both situations have real roots. So for this one, we know that the discriminant can be greater than or equal to 0, okay, since roots are real. Okay, for both those situations, greater than 0 when they're real and distinct, and equal to 0 for when they're real and equal. And then we're just solving that inequality. So 4 squared minus 4 times, oh, it's 2 there, sorry, not 1, times k is greater than or equal to 0, which is 16 minus 8k is greater than or equal to 0. So minus 8k is greater than or equal to negative 16. And when you divide by the negative 8, my inequality is going to turn around, so k is less than or equal to 2. Okay, and now there's just our statement. Again, we know that it's real roots, so we can make our statement and then we're just solving the inequality. The only thing you can do to make that trickier is make it a quadratic inequality, which we know we solve by doing a quick sketch and seeing where it is above or below the x-axis. Okay, first mark here is just for setting up your statement, and your second mark simply is just for solving. Okay, so given that k is a real number, so the roots of that equation are always real. Okay, first thing here is it's not equal to 0. We are talking about roots and being real, so we will be using a discriminant. So to use a discriminant, I need to have it equal to 0 first. So it's kx squared plus 3x plus 3 subtract k is equal to 0, and then I can use the discriminant. Now notice that I am not sure yet if the roots are always real, so I'm not making any statement at the start. I'm just finding out what my discriminant is. Okay, so b here is 3, a is k, and c is 3 minus k. Multiplying that out gives you 9 minus 12k plus 4k squared. So we've got our discriminant into a term involving k's. It's a quadratic term. Okay, you guys might prefer to rewrite that because you are more used to that k squared coming first. It's not a huge difference. Now, what we want to show is that the roots are always real. Now, as we've seen in the last question, the roots are real when b squared minus 4ac is greater than or equal to 0. So that is what we are wanting to show. And we do that by using our best friends when we're looking for positives or 0. We do it by proving the discriminant is a squared term. Okay, now looking at this here, this factorizes to 2k minus 3 and 2k minus 3, which really means 2k minus 3 squared. So because that discriminant is a squared term, we know that has to be greater than or equal to 0 because squares cannot be negative. Okay, and that's because since b squared minus 4ac is a squared term, it's greater than or equal to 0, therefore roots are always real. There is no situation where you're going to get a negative. Okay, now that's a tricky one, but if you're showing that something's always real, that means you're showing that they're always greater than or equal to 0, which means you're showing the discriminant is a squared term. Okay, marks. First mark is for getting your original term equal to 0. Your second mark is for your strategy for using your discriminant. Third mark for subbing incorrectly. Your fourth mark is for multiplying and factorising to a squared term, and then your fifth mark is for your explanation at the end. Okay, it doesn't have to be exactly that, but you do have to mention that it's greater than or equal to 0 because it is a squared term. Okay, question 7 now. The diagram shows part of the graph of the curve of the equation y equals blah 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 blah. Find the x coordinate of the maximum turning point. Okay, as soon as we start talking about turning points, we know that turning points are stationary points. We're talking about the discriminant, and more than that, not discriminant, sorry, derivative, and more than that when the derivative is equal to 0. So dy by dx, first of all here, differentiate that is 6x squared minus 14x and plus 4, and that has to be equal to 0. Dividing it through by 2 means that you get 3x squared minus 7x plus 2 is equal to 0. Not vital for solving, but it does make it a bit easier. And that means my factorization becomes 3x and x minus 2 here and minus 1 here. Because x is a third and x is 2. Okay, for the maximum turning point, you can see here that the 2 is the minimum turning point, the maximum turning point is here. So x is equal to a third. Okay, for part B, we are factorizing that term. Okay, so we know we're looking to synthetically divide and find one of our factors. So it'll be 2 minus 7, 4, and 4. Now, the factorization and solving that will give you your roots. We know what one of these are already. One of them's 2. So we can use that on the side of the factorization and speed things up a little bit, because that point there is a root, so it has to solve the equation. So 2, 4, minus 3, minus 6, minus 2, minus 4, and 0. So f of 2 is 0. Therefore, x minus 2 is a factor. And you can factorize that to become x minus 2, and then from your quotient, 2x squared minus 3x minus 2, which becomes then x minus 2, 2x and x, and minus 2 and plus 1. Okay, which is us done. That's us factorized it fully. Now for C, is then asking us to state the coordinates of the point A, which again is a root, and that's what happens when you set your original function or this factorized function to 0. And when you set it to 0, you're going to get two answers. X is 2 and x equals negative a half. Now the x is 2 is this point here. A is the point x equals a half. Negative a half, sorry. So A is the coordinate negative a half, 0. And then hence find the values of x for which this function or this polynomial is less than 0. Now you can see here on this graph, the only bit that is less than 0 is before it comes to A. So the y is less than 0 when x is less than A, which is less than negative a half. Okay, just 2 marks, 1 for getting your coordinate of A, and then 1 for the values of x or when y is less than 0. Right, marking 1 for setting your derivatives to 0, whether that's in the first line or the second, that's fine. 1 for differentiating properly. 1 for factorizing correctly. 1 for getting your answers, and then 1 for stating which one the maximum turning point is. Quite a generous marking there, but enjoy it while it's there. For part B, 3 marks, 1 for setting up the factorization properly, 1 for getting your quotient and your divisor together, and then 1 for factorizing. And then in part C, 1 for the point, and then 1 for the x is less than negative a half. Okay, question 8, last one, or sorry, penultimate one. For part A here, you're working with composite functions. So you're showing that f of g of x is equal to this here. So f of g of x is what happens when you put your g of x into your f of x. So x minus 1 is going into the f function. And that means every x here gets replaced with x minus 1. So it's x minus 1 cubed minus 2 times x minus 1 squared minus 5 times x minus 1 and then plus 6 at the end. And you just have to take a bit of time, go to the side of your question and multiply these out properly. Okay, so x minus 1 cubed becomes, when you multiply it out fully, x cubed minus 3x squared plus 3x minus 1. Okay, and forgive me for not showing you that. I'd imagine you're comfortable with that. You don't need to watch me breaking out brackets. This minus 2 times x minus 1 all squared. Be very careful with your signs here, your negatives. But it should end up being minus 2x squared plus 4x minus 2. So this bracket here becomes minus 5x plus 5, and then your plus 6 at the end. Okay, my x cubed at the start is only x cubed. Minus 3x squared minus 2x squared is minus 5x squared. Plus 3x plus 4x is 7x. Minus 5x is your 2x. And then negative 1 subtract 2 is negative 3. Add 5 is 2, and add another 6 is 8. Okay, and just double check. That's exactly what we're looking for. Okay, part B, I'm just going to come over to this side of the screen. Yeah, part B, factorise fully f of g of x. Okay, so f of g of x is what I've just been working with. It's terribly messy. Forgive me. 1 minus 5, 2, and 8. Okay, again, we're not given too much of a clue here, but we know we're working with factors of 8. So 1 minus 1, 2 minus 2, 4 minus 4, and 8 minus 8. I'm going to gamble on minus 1 and pretend that I didn't figure it out beforehand to make it easy for myself. Run it through, it gives you 0. So f of minus 1 is equal to 0. Therefore, x plus 1 is a factor. So f of g of x becomes the x plus 1 from my divisor, and then from my quotient, x squared minus 6x plus 8, which, when we factorise further, becomes x plus 1, x minus 4, x minus 2. Okay, that's you done. That's you factorise that fully. Now for part C, a tricky question that we're not massive fans of, but the function k is such that k of x is equal to 1 over f of g of x. For what values of x is a function k not defined? Okay, now not defined means when will it not work? And because we're looking at a fraction, k of x is not defined when the denominator of that fraction is equal to 0. Now, the denominator of that fraction is f of g of x. So it's not defined when f of g of x is equal to 0 because you cannot divide by 0. And f of g of x is equal to 0 when this is equal to 0. So when x is negative 1, when x is 4, and when x is 2. Okay, now that is when it's not defined. Because when f of x is 0, that means the denominator is 0, which won't work. Okay, let's look at marking. Okay, for the first question, the first mark is for setting up f of x minus 1, showing that you know that the x minus 1 is going into the function f. Second mark is for doing that correctly. Third mark, multiplying out, and fourth mark, just simplifying. For part B, setting up your factorization, the first step. Second step for running it through correctly, and then your third mark for factorizing properly. And for C, okay, your first mark, this is a bit, your first mark for getting f of g of x equal to 0. The third mark will be for solving. I think maybe they'll be looking for more work in here, but the second mark might be implied there because you have solved it and for knowing that that's got to be equal to 0. Okay, so there may need to be a bit more working in there when you're setting it equal to 0. Okay, but I think that will be implied in the third mark. Okay, if you write what I've got there, that's going to be enough. Okay, and last question, the diagram shows a sketch of part of the graph y equals x cubed minus 2x squared plus x. Show that the equation of the tangent to the curve at x equals 2 is y equals 5x minus 8. Okay, equation of a tangent is just the equation of a straight line. So we're looking for gradient and a point. Well, firstly, if we know that x is 2, we can get that point nice and easy just by subbing into y. So x is 2, y is 2 cubed minus 2 times 2 squared plus 2, which is 8 minus 8 plus 2, which is 2. So the point we're going to use is 2, 2. So now we just need the gradient. And the gradient of the tangent to a curve we know is always equal to the differential. The differential of this is 3x squared, 3x squared minus 4x plus 1. And again, we want to know what the gradient is when x is 2. So the gradient is going to be 3 times 2 squared minus 4 times 2 plus 1. 3 times 2 squared is 12, take away 8 is 4, add 1 is 5. So the gradient is 5, my point's 2, 2, so it's y minus 2 is equal to 5x minus 2. And then just breaking out the brackets and adding 2 to both sides is going to be 5x. 5 times minus 2 is minus 10, add the 2 from that side, gives you minus 8, which is what we are asked to find. Okay, part B, find algebraically the coordinates of the point where this tangent meets the curve again. Okay, so tangent meets the curve, that's a point of intersection question. So we know we're going to set up our points of intersection by solving simultaneous equations. Both these equations are equal to y. So let's make them equal to each other. X cubed minus 2x squared plus x is equal to 5x minus 8. Okay, and that's a polynomial equation. So it needs to be equal to 0 before we can solve it. So x cubed minus 2x squared minus 4x plus 8 is equal to 0. And we're going to set up our synthetic division to find the factors to solve this equation. Now, we already know one point of intersection. Okay, we know it happens at 2. So again, we can use that as one of our factors. So synthetic division 1 minus 2 minus 4, 8. I'm going to use 2 as a factor because I know that will work. So 1, 2, 0, 0, minus 4, minus 8, 0. Perfect. So f of 2 is 0, therefore x minus 2 is a factor. I knew that, but let's be clear. Which means this equation becomes x minus 2 from the divisor and x squared minus 4 is equal to 0. Which when we factorise again gives me x minus 2 and then x plus 2, x minus 2 from that difference of 2 squares in the second bracket. And that solves to x equals 2 or x equals negative 2. Now the x equals 2 is obviously this point that we already know about, this point 2, 2. So the other point of intersection where it meets the curve again is going to be when x is negative 2. Okay, forgive me, I'm just going to bring my work over here to the right. So when x equals negative 2, to find the y coordinate, I can sub back into either equation. I'll probably choose this 5x minus 8 rather than the cubic because it'll be nice and straightforward. So 5 minus 2 is minus another 8, minus 10 minus 8 gives you minus 18. So the point of intersection, or the second point of intersection, is going to be minus 2, minus 18. Okay, let's finish off by looking at the marking. So in the first one, 4 marks, 1 for getting your coordinate you need to use, 1 for differentiating, the third mark for getting the gradient, and then the fourth mark for subbing in and proving that is y equals 5x minus 8. And then in part B, we're looking at solving the simultaneous equation, so setting that up gets you the first mark. Okay, running it through gets you the second mark. Third mark for taking it out of the synthetic division, fourth mark for solving for x, and then the fifth mark for putting it back in to get your coordinate. Okay, so that's hopefully well, it is the majority or a good taste of the polynomials and quadratics past paper questions. Any issues, let me know. If you want me to do any other questions for you, just come see me. Okay, thank you very much. Bye now.